Okay, students, so let us start this chapter which is called ray optics or geometric optics. Okay, ray optics, ray optics and geometric. Ray optics is also known as geometric optics, geometric optics. So the first thing is that we need to understand what is the scope of ray optics. And there is another chapter of optics called wave optics. What is the scope of that? That means when do we apply the formulas or concept of ray optics, and when do we apply the formulas and concept of wave optics, because light can be taken as a wave or light can be taken as a rays. Light can be taken as a rays. So when do we apply the concept of ray optics? That means the concept of reflection, refraction, total internal reflection, dispersion, all this chapter what you will study, these phenomena are related to some limitations. It has got limitations. So what is the scope of what is the scope of what is the scope of ray optics? Ray optics. The question is, when can we, the question can also be written like that, when can the concept of ray optics be applied? When can the concept of ray optics be applied? When can we apply the concept of ray optics? So when light interacts with with optical devices like mirror, lenses, prism, slabs, etc. When light interacts with optical devices like mirror, okay, all these things, right? When light interacts with this, and the size of these optical devices is much larger than wavelength of light, then only ray optics is dominant. Okay, so try to understand what is the important point here. This chapter begins with this point. Okay, suppose if I give you some knowledge and I don't say that when can you apply this knowledge, then it is not very important. Okay, you will not be able to understand it. Suppose ray optics, you study everything, and when should you apply the ray optics concept, then only you will understand the limit of your knowledge. So this is the limit of the knowledge. The ray optics cannot be applied everywhere. Ray optics can be applied only when the size of the objects, that means mirror or lenses or prism or slabs, these objects light is interacting. So these objects, size of those objects should be much larger than wavelength of light. Wavelength of lights are in nanometers. Which light are we talking about? We are talking of visible light. Note that. Which light we are talking about? We are talking about visible light here. Wavelength of what? Wavelength of visible light. So wavelength of visible light is from 400 to 700 nanometer. 400 nanometer to 700 nanometer. So if the size of the object is much larger than the wavelength of light, then only the ray phenomena, ray optics is useful. Only ray optics, that means refraction, these things you can study, and these things phenomena will happen in nature. But if the wavelength is comparable, right? So here you should note that, suppose I will draw a diagram to understand this. Suppose this is a object and the size of the object is A. A is equal to object size. And suppose light radiations are falling on this. This is light and this is the wavelength is lambda. Lambda is the wavelength of light. Okay, wavelength of light. So if A is much greater than lambda, then ray optics phenomena is valid, like like reflection, reflection, refraction, dispersion, etc. Ray optics phenomena, this is the phenomena which we are going to study in this chapter: reflection, refraction, dispersion, all that thing. But if A is comparable to wavelength, then wave phenomena wave of light wave phenomena of light is valid. Wave phenomena of light, like what are those wave phenomena? Interference, diffraction, okay, polarization, etc. Okay, so these phenomena, interference, diffraction, and polarization, these you will be studying in wave optics. Wave optics is the next chapter, and this phenomena you will be studying in this chapter, which is called ray optics. Okay, so these two chapters, ray optics and wave optics, are very important chapter, right? But I am going to cover in depth of all these things, which are not also given in many textbooks, right? So ray optics we are going to start today. So let us start ray optics. Okay, so ray optics phenomena, already I told, reflection, refraction, all these things will be there. Wave optics, interference, diffraction, polarization, all these things will be there. Okay. Okay, done. Okay, let us go to the next one. We are starting ray optics. So first thing is, what is a ray? What is a ray? A ray of light, a ray of light represents the straight line path, the straight line path in which light travels. Okay, so light travels in a straight line, that is also known as Fermat's principle. So note Fermat's principle. Fermat's principle says that light travels in a straight line. Light travels in a straight line. That is one point. Second point, light travels in that path which take minimum time. Or you can say that light travels along the fastest path. Okay, so suppose for example light is going from point A to point B. If light is going, there can be various ways light can reach. All these are different paths, and assume that the same medium it is, same medium is same, so speed remains constant. And suppose I take path 1, path 2 and path 3. Three paths are there. So time taken in the first path is t1, time taken in the second path is t2. So here time t1, this time t2, time t3. So time in the first part, time is equal to distance. Let us call this as um, distance of this path is let us call as AB. Let us call it a x1 or L1. Distance is L1. L1 distance by speed v1. V1 is v only. Time in the second path, distance L2 by speed v, right? And time in the third path, distance L3 into. Now tell me, because time is equal to distance by speed, so time is proportional to the length. L is the path length. Because everywhere speed is same, right? Speed is same here in everywhere. Same speed, same speed, same speed. Why same speed? Because the same medium speed remains same, right? So if the medium is same, speed remains same. So time is proportional to the distance. So distance is small, so time is small. So for minimum distance, for minimum time, L must be minimum. And minimum length means shortest length. So shortest length is a straight line. That is what it means to be traveling along the fastest path. So fastest path means time should be minimum. Minimum time means distance has to be minimum, because here speeds are same. Here that is called Fermat's principle. Clear? So Fermat's principle. Then let us go to the next. Huh. Okay, let us go to the next. Next, first of all, we need to decide about what are the different types of rays. Types of rays. So first, um, paraxial rays, paraxial rays, and second, marginal rays, marginal rays. What are paraxial rays? Those rays which make very very small angle at the point of incidence. So you know that law of reflection, all of you know. Suppose if the rays are coming like this way and you draw the normal here, and you know the ray will reflect like this. Okay. So if I call this angle as I, this angle is R, you know that. These stories you know, there is nothing new in that. Okay. So the angle I is the angle of incidence, R is the angle of reflection. So I is very very small, very small. R also very small. How much is small? So much small that sine I can be written as I. So much small then sine R can be written as R. So much small that tan I can be written as I. So much small that tan R can be written as R. It's so much small. So that we can apply this approximation. That's the idea behind the small angles. So whenever the angles are small, we can write sin I as I, sin S R. Remember, the angles must be in radian. Angle must be in radian, right? Then only we do the approximation. Sin theta as theta. Theta is in radian. Angles are in radian. That you should note. Angles are in radian. They are not in degrees. They are in radian. Okay. So such rays are called paraxial rays. Such rays are, and here it is supposed that these angles are large angles, so they are called marginal rays. Okay. So those rays which make large angle, large angles at the point of incidence. That means I are there large. That means sin I cannot be equal to I. Sin R cannot be equal to R. Tan I cannot be equal to I. Tan R cannot be equal to R. Okay. Note that this is approximation, so I am not equating, actually I am making almost approximation here. This is approximation sign. Okay. We are approximating sin I as I because I is very small. Now note the second point, which is very very important point, that all the formulas of ray optics are derived by assuming, by all optics are derived by taking paraxial rays. Here all formulas means what? All formulas means all the formula which you know. No. What are the formulas? Mirror formula. Mirror formula. What is mirror formula? 1 by V plus 1 by U 1 by R. Lens formula. Lens formula. 1 by v minus 1 by u is 1 by f. Magnification formula. Magnification of mirror minus v by u. Magnification formula for lens v by u. All these formula are used only for paraxial rays. Clear? All the formulas are used for paraxial rays. Suppose the formula, suppose if the rays are making large angle, you cannot use this formula. You cannot use this formula. All your formula is wrong. Okay. This formula is used only for paraxial rays. Marginal rays, you cannot use. So only paraxial rays you can use this formula. So note here that these the formulas in ray optics cannot be used for marginal rays. So 1 by v plus 1 by u is not equal to 1 by f. Okay, like that, all these formulas 1 by v minus 1 by u is not equal to 1 by f. This is for mirror, okay, and this is for lens. These formulas are not or you can say this condition is for marginal rays, for marginal rays. 1 by v plus 1 by u is equal to 1 by f. These formulas are used for paraxial rays, but for marginal rays we cannot use this formula, so equality is cancelled. They cannot be equated. This formula is equated only for paraxial rays. For marginal rays it cannot be used. Clear? Are you clear about this? Yes. But again note one important thing, but the laws of ray optics is valid for any type of ray, whether marginal or paraxial. The law is law, right? Law is something which is never wrong. So the law of ray optics, like the law of reflection, that is valid for everything. So while deriving the formula, you have to use law. But in the last step of the derivation, you will make an approximation. That approximation will give those formulas, right? That approximation which you make now, that is only giving us those formulas. But if you don't use approximation, you will get new formulas, you will get different formulas. Okay, that is what it is. Some we will see. Let's see one very simple example of this. I think I have asked this question in this class also. So suppose this is a spherical lens, spherical mirror. Let us take it a concave mirror. Concave mirror. Let us consider this is a principal axis. All of you know principal axis. This point is pole, right? And let us take a ray of light which is making a large angle. This making a large angle. Okay, this angle is I, of course, and you know I will take this point as the center. Center means what? Center means this distance is radius r. Okay, this is radius r. And now let me take a parallel rays. coming like this way. From some point you take these parallel rays are coming like this, and parallel rays will go here. What do you think this point is called? Yes. What is this point? The parallel rays will pass. This is principal axis. Yes, this is focus. Okay, let us write as F. So this distance should be focal length F. But now I will prove that this is not the focus. Okay, that is what I am going to prove now. Let us see that. Okay. So, suppose if I draw normal at this point, normal I want to draw normal. You know the normal will pass through the center. I think this you know. Normal passes through center. Normal passes through center, right? So suppose this is the uh, or let us take this point as point. I think I should remove this ray. Might be I can remove this ray. Okay, let me remove this ray. This ray may not be useful. Okay, this ray may not be useful. So I am removing this ray. Right. So I have taken a ray which is parallel and it is hitting at the focus. This is the center of curvature. So this is angle I and this is angle R. We know that I and R. This total angle become I plus R, right? Total angle I plus, and I and R are same, so I am going to write this as I only because both are I. So this angle will become 2I. That also you know that because this total angle is 2I. That angle 2I. And note that this distance is nothing but radius only because this is radius, this length is radius, right? So this distance is R only, and this is I. Okay, I. So tell me, how much will be this angle? This angle is also transverse. This is parallel. So this is also I. Clear? So now look at this. Let us call this point as A. Look at this triangle. Look at this triangle FAC. This is I. This is I. This angle is 2I. So this angle will become 180 minus 2I. Right? This triangle you can see. And note that this distance is f, this total is r, so this distance becomes r minus f, right? So this distance is r minus f and this is equal to r. So in this triangle you can try to apply this sine rule apply, or you can see this is an isosceles triangle. So if this is r minus f, that will also be r minus f, isn't it? This is r minus f, that is anyway I are equal. Okay. So what do you want to do that from this triangle? I want to calculate f. I want to calculate f. So how to calculate f? Huh? How to calculate f? This is isosceles triangle. So, so I will use sine rule. All of you know sine rule. Sine rule in a triangle. So angle and side opposite you have to see. Suppose if I take this side r. So r divided by this angle is sine 180 minus 2I. And I take either of this r minus f divided by opposite of this is sine I. Sine rule I am applying to calculate f. Now let us calculate that. So our sine 180 minus 2I also becomes sine 2I. I hope you know that. R minus f by sine I. Now sine of 2 theta is 2 sine theta cos theta. Right? R minus f by sine I. Now I will cancel sine I both sides. So from here I get r by 2 cos I is equal to r minus f. I'll bring f one side is equal to r minus r by 2 cos I. R I will take common and this is a new formula for focal length. Now you tell me, is is f equal to r by 2? You know that, right? F is equal to r by 2. All the 9th, 10th student, you ask what is the relation between focus and radius, they will say f is equal to r by 2. Radius is 2 times of focus, but no, tell them it is not correct. Okay, this is the actual formula. Focal length is r times 1 minus 1 by 2 cos I. Now suppose angle I is very small. So if angle I is very small, so cos I becomes 1, because cos 0 is 1, right? Cos 0 is 1. So cos I, now you take approximation for a small angle. For I to be very small, cos I becomes 1. So f becomes r into 1 minus 1 by 2, 2 into 1. So now you see r times 1 minus half, that gives r by 2. Clear? So focal length is equal to r by 2 only when angle is very small. Only when I is very small. Are you understanding this? Yes? You can use, but you should know the angles are very small. Huh? Angle means these angle of incidences, the angle of incidence, angle of reflection. What you are saying? How much angle you are asking? How much angle, right? Angle must be, see, angle must be less than 5 degree. Less than 5 degree if it is, then you can use it. Less than 5 degrees you can use. 2 degree, 3 degree. The smaller the angle, better is the accuracy, because it's accuracy. You know what is accuracy? I will tell what is accuracy. Just wait 1 minute. Tell me the expansion of sine. Tell me expansion of sine theta or sine x. Tell me approximation of sine x. Come on. Expansion. Have you studied that? Expansion of sine x. No. Anyone? Sine x expansion. Maclaurin's theorem. Nobody has studied. What is this? Huh? Sin x expansion is x minus x cube by factorial 3 plus x5 by factorial 5 minus x7 by factorial 7 plus x9 by factorial 9, and like this. This is called sin x expansion. Expansion of sin x. Okay. Now, suppose if I consider x very small, very small means very small as compared to 1. Remember, this x is in radian. X is in radian. And x is very small compared to 1. Then what happens is that, for example, take x as 0.001. Let x be, or let's take 1 degree. Let us take 1 degree. 1 degree is how many radian? Calculate. 1 degree is pi by 180 radian. What is pi by 180? Tell me fast. How much is pi by 180? Calculate. Nearly 0.017. 0.017. Correct? 1 degree is that much radian. Yes? 1 degree is 0.01. Now tell me what is sine 1 degree. Sine 1 degree, sine radian means 0.017 radian. See here, degree is not used. Note that x is not in degree, x is in radian. So convert 1 degree into radian. Then you can use this formula. So that will become 0.017 minus 0.017 whole cube by 3 factorial. I hope you know that is 6. Yes. Then plus x power 5, 0.017 power 5 divided by 5 factorial. How much? 5 into 4 into 3 into 2. How much is 5 factorial? Tell me. 5 factorial is 5 into 4 into 3 into 2 into 1. How much it is? 5 into 2, 10. 4 into 3, 12. 1.8 is. Okay. So you can expand this. Yeah, like this. So like that you can keep on expanding the other term. Now tell me how much this term will come. You can think about it. You don't have to do much. 0.017 cube means 3 times you have to multiply this. And this is quite small. So if you multiply 3 times, it is almost going to be very, very small. And that too you are dividing 6. So this is going to be almost 0. Right? Are you understanding? That is why you have to neglect these terms. You have to neglect these terms. Right? That is why you have to write only this much. So sine of 0.017 radian means it is 0.017 almost. Are you getting it? This is maths. Okay. So that is why I am asking you that you can write this approximation. Now see, when it's a fraction, now fraction you can write. So up to 10 degree, if you try to approximate 10 degrees, you can write only first term. And if you write first term, then there it's not that it's 100% accurate, but there will be error. Even sine of 10 degree can be written in terms of this radian, and first term you take, but that will be accuracy up to that. Error will be there. If you write two terms, there will be better accuracy. If you write three term, more accuracy. If you write four term, it is the most accuracy. Like that, accuracy will increase if you write more terms in the calculation. But if you write only one term, there will be error. More error will be there if you write one term. But it depends on error is how much. If error is very small, we can just use the first term. So if you use up to 10 degrees, error may be less. Errors are not more than 4-5%. So even 10 degree can be also approximately written. 10 degree means how much? 0.17 radian. 0.17 radian it will be. And 0.17 radian, here q will also become small only. So you can use only first term. Approximately you can do, but you should know this is approximation. This is approximation. So sine of this can be approximated it to 0.017. You need to understand this is maths. Okay? But anyway, I hope you got this. Why are we doing it like this? Yes. No, no, that we cannot do. We cannot do that. For that we have to for suppose the angle is very large, let us say sine 30 degree it is. Okay, let us say the incidence is happening at sine 30 degree, means suppose this is a mirror, concave mirror, and this is the principal axis. Okay, and you are taking this ray which is going very far away, like this it is going, and with the center, when you drop this angle of incidence, right, this is coming, let us say 30 degree. Then here you cannot apply for this ray is what is marginal rays. Okay, you have to know this is marginal rays because it is making very large angle. So that formula we cannot use. So for this actual formula you have to use. So f is equal to r 1 minus 1 by 2 cos I you have to use. Now use this formula. So r 1 minus 1 by 2 cos of 30 degree root 3 by 2. Okay. So 2 will get cancelled. So it will become r 1 minus 1 by root 3. This is the formula for focal length. Formula for focal length will be this. But why are we taking formula surface r by 2, because we are considering, try to now understand, we are considering this mirror like this, and we are taking this principal axis like this, and we are studying rays only nearby here. These rays only we are studying, these rays only we are studying. This area is very much limited, this size is very much limited, very small size it is. Okay, so the formulas which you are deriving, all those formulas you are deriving near to this small area, very small area. So here the angle should be considered very small. Are you understanding? Here the angle should be very small. That is the reason its aperture size is very, that this is called aperture size. Okay, this is called aperture. This is aperture. So this aperture size is very small, very small. Okay, so that is why this is a very limited formula that we are studying. But this type of question will come, then only those who have the proper idea they will solve it, because then you know this ray is not these rays are paraxial rays. Okay, these rays are paraxial rays. These rays are paraxial rays, and these rays are marginal rays. So only for paraxial rays we can use, for these rays we can use f equal to r by 2. But here we cannot use f equal to r by 2. We have to use this formula for that. Clear? Are you clear about that? Okay, done. So then what? Okay, other type of beams, you should know what are the different types of beams. Let us discuss the types of beams quickly and then go to the law of reflection. Type of, so one type of beam is like, beams are made up of rays. Okay, beams is a collection of rays. Beam is a collection of rays. Collection of rays. Now, if you take this type of beam, this is called parallel beams. Parallel beams. Because they are neither converging nor diverging, the distances between these remain same. Let's say this is the diameter, this remains constant. But we have other types of beam which is called convergent beam. Convergent beam means the beams are going to converge like this. So radius will, or diameter will keep on decreasing. Here if you take this diameter is larger d1 than d2 smaller, like that. So here d1 is larger, d2 is smaller. Radius or diameter is decreasing, that is called convergent. And the third one is called divergent. Divergent beam. Divergent beam means it will be like this. Divergent. So the radius will keep on increasing. So if I take this as radius or diameter d1, d2, so here d1 is going to be smaller than d2. So note that these rays are going in this way. Rays are going, and along the path of the ray, diameter increases. So diverging along the path of the ray, diameter decreases. That is called convergent. Along the path of the ray, there is no change in diameter, same diameter, parallel beam. Clear? It looks like theory, but these theories are important initially. Done. So now we are going into the rays. We are going into the reflection. Law of reflection. We'll go into the law of reflection. Law of reflection. Suppose this is a mirror, plane mirror. and a ray of light is coming like this. If I draw normal, normal means it is perpendicular. This ray will go like this. This is called incident ray. This is called reflected ray. This is normal. So this angle is called angle of incidence. This is called R. I is angle of incidence. R is angle of reflection. So what is reflection? A ray of light is traveling from one medium and it is trying to hit a optical surface. This mirror is also called optical surface. Optical surface or boundary. So at this boundary, when it is hitting it, light cannot go inside the boundary, light cannot go inside that medium, so light is returning backward, it is bouncing back the same medium. So what is the law? The law says two things. First, this angle of incidence is equal to angle of reflection, and the incident ray normal and the reflected ray all lie in the same plane. In the same plane. Same plane. Right, so that's the law of reflection in grade 8, 9, 10th you have studied. Now we will discuss the vector form of this. So suppose that there is a unit vector in this direction. Unit vector means its length is 1. Okay, and it's a vector. So let us represent this as E I cap. Similarly, there is a unit vector in this direction E R cap, and similarly there is a unit vector in this direction E n cap. Okay, so these are unit vectors in these directions. EI is unit vector in the direction of incident ray, ER cap is unit vector in the direction of reflected ray, EN cap is unit vector in the direction of normal, outward normal which is coming out. Right. So now we want relationship between them. Okay. Let us say that this angle I is theta. This is also theta. I and R are theta. Let us say that. Okay. So let us define this as x-axis. This I have defined as x-axis, and this I have defined as y-axis. So unit vector along x-axis, I cap. Unit vector along y-axis is j cap. So let us write this En cap. En cap is opposite of y-axis. It's negative y-axis, so minus j cap it is. What about Ei cap? How to write Ei cap? So this Ei cap, let us resolve. Okay. So this is Ei cap. Its magnitude is 1, and this angle is how much? So you see this angle is theta. So with the vertical it is making angle theta. Okay, with the vertical it is making theta. So this will become cos theta, and this will become sin theta. 1 cos theta, 1 sin theta, because its magnitude is 1. So this Ei cap we can write as sin theta I cap plus cos theta j cap. Its magnitude is 1, so we can write it like this. Okay. Then similarly, try to write this ER cap. So this vector is like ER cap. Its magnitude is also 1. Note that it is making same angle theta with the vertical. So this also will make same angle theta with the vertical. So let us resolve this. So this also become cos theta. This also becomes sin theta. So we can write this ER cap as sin theta I cap minus cos theta j cap. Okay, we can write this ER cap and EI cap like this. Now tell me what is what is the dot product of um, EI with EN. Let me take dot product of EI, EN cap. When you take dot product, you know components you have to multiply. Here there is no I component, so you don't have to take I. The j component is cos and it is -1, so that become minus cos theta. Right? Similarly, if I take dot product of ER cap with EN cap, then minus cos and minus minus will become plus, so that will become cos. Now we want to find relation between EI, ER and EN. So let us do this. Let us subtract ER minus EI. Let us subtract. When you subtract, sin will get cancelled. This minus cos and minus cos, it will become minus 2 cos theta j cap. Now note that. Okay. Minus j cap I can write as En cap. So this becomes 2 cos theta En cap. Okay. And this cos theta I can write as ER En, or cos theta I can write minus EI En. Okay. So let us write that. So this becomes ER cap minus EI cap. So this, let us write this in terms of cos theta. So cos theta can be written as minus. So minus 2 EI cap dot En cap. Okay, and that is En. That's what we are writing. Let us keep in brackets. These are dot product. Now from here, what is ER cap? So ER cap can be written as EI goes that side. So EI cap minus 2 EI cap dot En cap En cap. This is the vector formula, or vector, not formula, law. This is law. Law is not limited to any condition. Law is valid everywhere. Okay, so this is the equation of vector law, law of incidence in vector form. That also, this is the first point of the law. Second point, already I told that these are lying in the same plane. That means if the three vectors are lying in the same plane, means they are coplanar. Coplanar means you can take cross product of any two, EI cross ER. When you take its dot with EN must be 0. Okay, dot A cross B dot C, or you can like a square bracket like this, EI ER cap En cap. This is equal to 0. This is written like this, is triple scalar product. Triple scalar product is represented like so. This is the second point in the law. Okay, second point. So this total point 1, point 2. This is the law of vector, law of reflection in vector form. First point, second point. Clear? Are you clear about this? Yes. Okay, so done. This is the law of reflection. Then we are going to see also what is object, what is image, and what is real and what is virtual. Object and image, real and virtual. Huh. Okay, done. So let us go to the next. So try to understand what is object means. Object is made from incident rays. What is image? Image is made from reflected or refracted rays. So using the refracted or in case of reflection we will use reflected rays. In case of refraction we will use refracted rays. So use these rays to make the image. And for incident rays, if you use, let us say incident rays are meeting or it appears to meet, using incident rays you can only make object. Okay, that should be clear. So now let's understand real and virtual. Real and virtual means, real means if the rays actually intersect, actually meet, and virtual means if the rays if the rays appear to meet if extended, okay. This concept, first of all we have to get this very important concept. What is real, what is virtual, what is object, what is image, very very fundamental. Now let us understand, see, two examples I will take. One example is plane mirror like this, and there is a incident rays are coming like this. This is incident rays are coming. These rays are incident rays. I am taking them as incident ray. This is also incident ray. So this incident ray, when it will go and it will hit the mirror, here also it may hit the mirror somewhere. Okay. Let me take that not meeting. Let us take like this. Let us put like this. These two rays, they will hit and they reflect. I am not showing the reflected ray, okay, I am showing incident rays. These incident rays are not meeting because mirror has come in between, so actually they are not meeting. Backward also they are not meeting, right? Even if you extend them backward, it is not going to meet, right? But because mirror has come in front, it is not meeting. But let us say you extend them. Now you extend them forward. This I am extending it forward. It appears to meet, right? The incident rays you have extended forward, it looks like they are meeting. So this is what is a object. Object. Now tell me what type of object is? Are the rays actually meeting? No, rays are not meeting actually. So this object is a virtual object. This object is a virtual object. Okay. Okay, now here also look at the reflection. Suppose reflection you take, the rays will go like this. Here rays also will go like this. So these reflected rays are actually meeting here. The reflected rays are meeting here, and these reflected rays are actually meeting. So this is real image. Real image. Okay. So real image, virtual object. Similarly, suppose mic fell down. Okay. Fine. Now it is clear. Are you able to hear me? Okay. So just now we'll take a reverse case. So suppose this is a mirror, and let us say that there is a object. Now I will take this as a real object. Why real object? Because instant rays are coming out or it is emerging from it like this way. These are incident rays. Now after reflection from the mirror, they are going like this way. These are reflected rays. This is also reflected ray. Now these reflected rays are diverging, they are not going to meet, but when you extend them backward, it will appear to meet here. This is what is image, right? What type of image it is? These rays are not meeting actually because they are diverging, but they are meeting when extended. This is virtual. So this is virtual, but it is image. What to do? This is image. So this is virtual image. Okay. So plane mirror can form virtual image for objects which are very nearby or in front of it. So if object is in front of it, real object is in front of it, it will form virtual image. But if there is no such real object and rays are coming like this from somewhere, then you can assume that there is a virtual object inside that. Okay. See, yes, convergent incident rays will make virtual object, and divergent reflected rays will make virtual image. Okay, okay, we can say that. So this is the concept of object and image. Then let us go into the concept of image, characteristics of image formed by plane mirror. Characteristics of image formed by plane mirror. Characteristics of image formed by plane mirror. So first characteristics, that object distance is equal to image distance. Suppose this is a mirror and suppose this is an object, the image will lie exactly inside it, and suppose if I measure the position of object like this is the position of image. But remember, this is with respect to mirror because you are measuring with respect to mirror, and that too you are measuring in the perpendicular direction, perpendicular you are measuring. So the perpendicular distance will be equal, but their positions are opposite of each other. So we can say factorially that XOM is minus XIM. So you can say XO minus XM, relative position, is minus XI minus IM. So that becomes XO minus XM is minus XI plus XM. So XO plus XI is 2 times of XM. This formula comes. Okay. What is XOXM? XOXM is the perpendicular position of the object or image from the mirror. Perpendicular direction. Okay. Perpendicular direction. So positions are measured in perpendicular directions. And suppose, for example, this objects move. If this object move, you can differentiate this. This will be the velocity of object plus velocity of image is 2 times velocity of mirror by differentiating it. Okay. If you differentiate, you will get this differentiating position. After differentiating position with time, you will get velocity relationship, right? So that's what it is. But remember, these positions or velocity, position and velocity are perpendicular to the mirror. Perpendicular to the mirror. These velocities are perpendicular to mirror means what? Perpendicular means they may be going like this way. This is the perpendicular velocity, or this may be like this. Of course, it will go in this direction. Okay. Or let me write like this here. Mirror also may be moving like this. Yeah. All these velocities which I have taken, note all these velocities are in this direction. All these velocities are horizontal. All of them are moving in this perpendicular direction. Perpendicular direction means perpendicular to mirror. Perpendicular to mirror means what? Perpendicular to mirror means this direction. This direction. Okay. This has to move in this way. Any other direction is given, you have to resolve it. Note that. Any other direction is given, you have to resolve and take only this component. You cannot take any other component. Okay. Other component does not change, that you know. Other component of velocity does not change. Clear? So that's the first important thing. Second thing is magnification is equal to 1. Magnification is equal to 1. That means what? Object size is equal to image size. Image size and object size are same. Then next, object image are same size. Then third, object size and image size are same. Then what? Image image is virtual. Image is virtual. We are seeing object. We are taking real object. Okay. Image is virtual for real object. Real object we are taking. Then image is laterally inverted. Laterally inverted with respect to object. What is lateral inversion means? Suppose if this is mirror. Yes. Yes. Suppose this is A and this is B. In the image which will be formed, this point will become B, this will become A. Okay. So left has become right and right has become left. That's what happens. Okay. That is called lateral inversion. And what is the reason behind it? Why it happens? Because the rays which is going in this direction, perpendicular direction, reflection takes place. Ray of light reflection takes place perpendicular direction. So inversion happens in this direction. In parallel direction, there is no inversion happens. Right? Suppose for example, this person is moving parallelly. So image will also move parallelly. But if this person moves towards the mirror, image also moves towards the mirror. That happens because of that perpendicular direction. There is inversion. Okay. Done? Clear? So suppose for example this is a mirror and let us say that there is a object and this object is moving like this way. Let us say it is moving like this. The image which will be there, this is the image, this is the object, this is image. Image should move also in this manner, making the same angle theta here. So the orientation of this and the same speed will be there. The orientation of object and image with respect to mirror will be same. Remember, here I am taking the mirror to be at rest. This mirror is rest right now. Or this velocity is the relative velocity which we are taking. Right? Relative velocity we are making. Okay? Okay, I think these are all the important points. I hope now you can understand this. Then what next? Law of reflection. Now we are going to take the formulas for deviations. Deviation. Deviation of a ray. Deviation of a ray with plane mirror. Suppose that this is a plane mirror, and if there is a ray of light is coming like this is the normal direction, normal. This ray will go like this. We know that. Suppose this angle is I, this angle is also I because this is equal to R, I and R are equal. Now suppose if this ray was going like this, if mirror was not there, it would have been going like this way, right? If mirror was not there, this would have gone like this. So this ray has turned or it has rotated like this. This angle of rotation you can take as deviation. This is called deviation. Now if I add the total angle, that means this deviation plus I plus R is going to be 180 degree. So deviation will become 2I because I and R are equal. So from here deviation formula is 180 degree minus 2I. Okay, this is the formula for deviation. Deviation of a ray from this. Next. Also note that this angle which is 90 minus I, it's called glance angle, theta glance. Okay, theta glance. So this angle is also going to be theta glance, and this angle also going to be theta glance. So deviation can also be written as 2 times the glance angle. 2 times the glance angle. Right. Then what? Deviation. Then what about rotation? Let us take rotation. Suppose this is a plane mirror and there is an incident ray which is coming like this way. Now suppose you keep this incident ray fixed. Incident ray, fixed incident ray. And let us rotate the mirror. At this point, let us rotate the mirror by some angle theta. This is the angle theta by which you have rotated the mirror. Then what happens? Normal will also rotate. Note that previously the normal was like this, and this angle was the angle of incidence. And here the reflected ray was like this. The reflected ray was also making the same angle incidence. But because you have rotated, the normal also is going to rotate. Now the normal will be to this surface, normal you have to draw. So to this surface, normal you have to draw like this. This is new normal. So with the new normal, the new angle of the incident will be how much? Because normal has rotated the same angle theta as you rotate the mirror, because normal is a fixed to the mirror. As you rotate mirror, normal also rotate by theta. So now with the new normal, it will make how much? I minus theta. I minus theta is the angle made. So the new reflected ray will come in this manner. I am showing dot dot dot. This will be coming here like this, and this will be also making the same angle I minus theta. Okay. So the reflected ray is now the new reflected ray. Previously the reflected ray was this, right? This is the new reflected ray. So how much is this angle? Because this total angle is I. This is I minus theta, I minus theta, 2I minus theta it is become. Correct? So tell me how much will be this angle? This angle will be how much? because this is I minus theta, this is theta, so that will be theta minus I minus theta. This angle will be theta minus I minus theta. So this angle will become 2 theta minus I. Okay. So now tell me what is the angle between the new reflected rays. This is the new reflected ray and this is the previous reflected rays. So what is the total angle between these two rays? You see this is angle I and this is 2 theta minus I. So angle between reflected rays, angle between reflected rays is equal to I plus 2 theta minus I will get cancelled, it is 2 theta. So that is the meaning of this. So if you rotate the mirror by some angle theta, reflected rays rotate by 2 theta. Okay, if mirror rotates theta, then reflected rays rotates by 2 theta. That means what? The angular velocity of reflected ray is 2 times angular velocity of mirror. This we should know. Angular velocity is nothing but how angle are changing with time. So if angle becomes theta, reflected ray will makes 2 theta. Okay. So I think let us wind up to here. We cannot, I think, cover because so many things are detailed out there, right? This chapter is so much in details. So we cannot rush it, otherwise, we can simply write formula and wind up the chapter. But lot of concept, very high weightage topic this is. So we will wind up here. Next class we will cover up tomorrow. We'll see we can cover up more theory and let us try to wind up tomorrow. Okay, correct. So then means maybe tomorrow afternoon I will take to cover up this topic, and doubts also we can take tomorrow. Fine. Okay then. Then we will see next class. Sam. Okay. Bye bye. Good night.